This is ASFurther Maths, and we're looking at chapter 4 vectors, and we've now moved on to the vector equation of a straight line. So in vector terms, a line is defined by a vector that is parallel to the line and a position vector of a point on the line. That won't make too much sense yet, but I'll explain just kind of in a wee second. So let's see where it's all coming from then. So if we position vector A going to here, position vector R going to here, and a vector parallel then to this line here, we can then define this line here. So the way we do it is we go consider a general point R on the line with position vector R, and then since AR is parallel to B, then AR is some sort of multiple then of B. So if it's parallel, like two parallel ones, like I plus 2j must be parallel to 3 plus 6j, if you kind of think about it like that. So AR is some sort of, and we call that then lambda B, and AR is equal to minus A plus R. So where are we getting that from? How do you get from A to R? Remember back at the start of the chapter, minus A plus R. So hence minus A plus R equals lambda B. And so our equation of the line, and this is the one you need to learn and know and love, I suppose, is R equals A plus lambda B. That then is our general vector equation of a straight line. A is any point on the line and the B gives then the direction the line is going. And that's how we work out then our vector equation of the line. It makes a bit more sense if we chat a wee bit longer about it. So let me pause and get back to here. So here's how I think about this. Let's think about a normal equation of a line. Say we have something like y equals 2x plus 1. I hope people know what that means and what it looks like back kind of from year 10 sort of level. So as you put in different numbers for x, you get out different numbers for y, and it plots different points. Let's try 1, 2 and 3. If I put the number 1 in here for x, I get y equals 2 times 1, so I get 3. If I put 2 in, I obviously get 5. If I put 3 in, I get 7. So it means the point 1, 3, 2, 5 and 3, 7 then are on this line, and that then is what generates the line. If it's a vector equation of the line, it's R equals A plus lambda B. Let's pick a wee random point on the line. So let's say we know the line goes through this point here. That's the point 2, 3. That's your position vector on the line. So an example here would be R equals 2, 3. Now remember, I can write that as 2i plus 3j if we want. And then lambda B, let's go for, I don't know, let's go for 1, 4. So give me a second. So this effectively then generates any point that we want. You put in the same way here, you put in different values for x to get out different values for y. Here we put in different values for lambda to generate different points on this. So if I put lambda equals 0, we end up with 2, 3. So there's a point on it. If I put lambda equals 1, it means you multiply 3 by 1. So 2 plus 1 is 3, 7 then is going to be on this. Wait a minute. I've made this point wrong, haven't I? How confusing, how annoying. That's 3, 2 actually, isn't it? So it's actually 3 across 2 up. So that's your point on the line, seriously. And then 1, 4. So that's going to give me then the point 4, 6. So across 4 and up 6. And effectively, any time you put another number in here, you go across another 1 and up 4. So I put the number 2 into here. It's going to give me 3 plus a 2. It's going to give me 5. And then 2 plus, it's going to give me 10. And so that then will generate that point there. If you put minus 1 in, then kind of goes back this way here. But that's effectively what you have. Now, another thing worth noting is that there are so many different ways of writing this same equation. This here would generate the same point in the line. Let me see, this is a point 4, 6. That's the same line. This is a point on the line, and this is the direction it's going. And you just end up then with the same line. Loads of different ways of representing the same line. Let's take a look at example 1 then. Find the vector, it should be find a vector equation of a straight line parallel to 2i minus 7j and passes through the point 3i plus 2j. So our formula is r equals a plus lambda b. So it's going to be r equals, this is a point on the line, so there's your point on the line, so it's 3i plus 2j plus lambda upon, it's parallel to this one, 2i minus 7j. That's it. That's your answer. That's it, done. You can write that in column form if you wish, so you'd have a 3 over a 2 here, and then a 2 and a minus 7, and that's you done. Example 2, with a wee bit more to do, but that's okay. Find the vector equation of a straight line passing through the points A, B, C. So I'm not going to draw this out accurately, but say we're in 2D here. Let's say here are our 3 points, and these are the 3 position vectors of them. What do we need? We're trying to find the vector equation of this line, so we need to know the direction it's going. That's the B bit. And then we need to know a point on the line. We've already got 3 points on the line, so that bit's no hassle. So it's going to be r equals a plus lambda b, and we need to find in the direction that the line's going. So if we have this as a, this is b, and this as c, then now the line can either be going this way or this way. That doesn't really matter. So how would we get from here to here to kind of get this direction here? That would be minus a plus b. So we can get it using that. So we get a direction vector, which is the b bit. Now it's different from that b, I suppose, which is a bit confusing. And that's going to be minus a plus b, or if we want then b minus a. So that's going to be 2, 7, take away minus 1, 1. 2, 7, take away minus 1, 1, so that would give me then 3, 6. So that then is the direction it's going. So I have a point on the line, any of those 3, and I have the direction that it's going. So a vector equation then of a straight line here would be r equals the a, let's go for just the first point, minus 1, 1 plus lambda 3, 6. So again, how would that work? That's our answer done. We're done with this question, but just to show you how it's working, you would plot the point minus 1, 1, so back 1 and up 1 if you're on a coordinate plane, and every time you put 1, you're going across 3 and up 6, across 3, up 6, across 3, up 6. Incidentally, another line which would be equivalent to this, as in the same line, if you want, it would be r equals 2, 7 plus lambda 3, 6. Another one would be r equals 3, 9 plus lambda 3, 6. Incidentally, another one would be r equals minus 1, 1 plus lambda upon 1, 2. Going across 3 and up 6 is the same as going across, across 1 and up 2. It just takes things in the same direction. It would just be different values of lambda to plot the different points, but you'd get the same line effectively. And so it's getting used to that and knowing then where it's coming from. Finding a point then of intersection. So to find the position vector of a point of intersection then of these 2 lines, we need to set it up. So we're going to let P, So let P be the point of intersection of the lines. Then that must mean P must equal, I'm just going to write that as 2, 1, we'll change it into a column form because it's easier, plus lambda. So there's some value of lambda that gives you P, and there's some value then of mu that must give the same value then of P as well. So we can equate our coefficients. What does that mean? We can take the I bits and put them equal to each other. So we can go 2 plus lambda must equal 6 plus mu. If I rearrange that, I'm going to get lambda take away mu equals 4. And we'll call that equation 1. Hopefully you can see where this is going. So that was me doing it for the i's. For the j's, then we're going to have 1 plus 3 lambda equals minus 1 minus 4 mu. Rearranging that, we're going to get 3 lambda plus 4 mu equals minus 2, and I'm going to call that one then equation 2. What way do we want to do this? I guess we could kind of sub one into the other. If I rewrite 1, lambda equals mu plus 4, and then we sub into 2, we would get 3 mu plus 4 mu equals minus 2. 3 mu and 4 mu, we're going to get 7 mu, and then that's going to be 12, so minus 14. That gives me then mu is minus 2. If I sub minus 2 into there, that gives me then the lambda is equal to 2. So where is my point? If you sub lambda is minus 2 into here, it's going to give you a point P. It needs to be underlined. If I sub, what did I say, mu? If you sub mu is minus 2 into here, or if you sub lambda is 2 into here, it should give the same value. So we'll try first of all lambda is 2. P then equals 2, 1 plus 2 upon 1, 3. That's going to be 2 plus 2, so I think it's a 4, 7. So if you want then 4i plus 7j, and then let's check. Mu is minus 2. Check that it works for that. So it's going to be 6 minus 1 minus 2 upon 1 minus 4. So 6 take away 2 is 4, minus 1 plus 8 is 7, and so it works. Therefore, our point is 4i plus 7j.